So in the previous set of videos, we had a discussion about and learned about inheritance. It's time now to talk about composition. Composition is another component of object-oriented programming and is very useful in day-to-day programming. But just as a refresher, I'm going to start off and just go over inheritance very briefly before we move into composition. Best way to do that would be an example. So let's create two quick classes. First one's going to be vehicle. The vehicle is going to be very simple. It's going to have one field, private string name, and it's going to have a constructor. Very simple concept of the vehicle. Let's also create another class, call it car. We're going to extend from vehicle and add a couple of fields, so number of doors, private int, engine capacity. Set up a constructor, and there we go. Very simple little example. So the car extends from vehicle. Now it's got a relationship with vehicle. Is a meaning that a car is a vehicle. So that's the relationship between the two. So you can quite correctly say car is a vehicle. And that's essentially what inheritance is. But composition deals with something different, and that deals with a has a relationship. And the best way to do this is to go through an example. So let's look at the scenario of a computer. So a computer has a motherboard, a case, and a monitor. Three example things that it's got with it. So the motherboard, the case, and the monitor are not computers in the same sense that a car is a vehicle, but a computer has a motherboard, a computer has a case, and a computer has a monitor. So that's what composition is. It's actually modeling parts, if you will, parts of the greater whole. So in this case, we're going to model the computer, and we're going to model the has a relationship, so the motherboard, the case, and the monitor. So let's start off by actually creating those three classes, the motherboard, the case, and the monitor. So I'm going to start with the motherboard, new Java class, motherboard. We're going to create some fields, string model, private string manufacturer. That's the manufacturer of the motherboard. Private int, the number of RAM slots that the motherboard's got. And the number of card slots for video cards and so on. And lastly, just the name of the BIOS. Just some typical things that you would find in a motherboard. So we're going to create our public constructor, which will just be all the fields. We're going to create getters for all our fields because we don't need setters. But what we're going to do is add one public method, which we're going to call a load program. We're going to pass a parameter, which will be the program name. And we're just going to print out that the program name is now loading. So that's our motherboard class. Pretty straightforward, as you can see, nothing particularly complicated there. So let's now move on to our monitor class. We create another new class. Monitor is the name. It's also got some fields. We're going to start with the private string for the model. Private string manufacturer. Private int size, that'll be the size of the screen. And let's go with another one, which is going to be the native resolution. We're going to call that resolution. Native resolution. And resolution is going to be a class. And I'm going to create a constructor. Like so. And we're going to fix up that resolution class in a minute. We're going to create that class. And what we're going to do here is we're going to create a public method, draw pixel at. And it's going to have an X, Y location, and let's just say a color. And we'll just do a simple message that says drawing pixel at X, the XY position in color. Very simple method, and then we'll just create some getters as well. Just the getters for this class. So next we need to create the resolution class. And with the resolution class, that's going to be the native resolution. So what is the width and height, the maximum width and height of the monitor? How many pixels wide and how many pixels down, so to speak. So we can go for width and height. Let's just keep it simple there. So that will be the resolution, constructors, and some getters. So that's our resolution. So going back now to the monitor, we find that error's now gone away. So this is an early example. We're going to talk more about this shortly, but this is composition. So the resolution class is part of a monitor. So the monitor isn't a resolution, but it has a resolution. So this is what composition is. So we're saying that the resolution is a component of a monitor. The monitor has a resolution, which is the native resolution. But more on that shortly. So next we need to create our class for case. A new class, case. And we're going to have model, private string, manufacturer, private string, power supply. And let's also have a dimensions. Dimensions. It's a new class we're going to create. Which is going to be the dimensions, width, height, and depth of the actual case itself. This is the case that contains all the components. And so the constructor is going to have to accept those parameters, like so. We're going to create a function called press power button. And we're just going to have a simple print line that says power button pressed. Like so. And we'll just do our getters as we normally do. Okay, so we're making good progress now. So the last thing we now need to implement before we can start seeing how some of this works is, of course, the dimensions class. And that's going to have a width, a height, and a depth. So let's create that. So dimensions. And it'll be width, height, and depth. Create a constructor for the three of them, and let's create a getter as well. Oops. Like so. So there's that dimension. So now if I go back to case, the error goes away. So the case has got a model, a manufacturer, and a power supply. A case has got dimensions. The dimensions which are so the width, the height, and the depth. That is what our dimensions is. So of course the case has got all these things. It has got a model, has got a manufacturer, has got a power supply, and of course it does have dimensions. And that's what we're doing here again with our composition, is we're actually creating something, in this case another object, that is part of the case. So now we get to the fun part where we actually create a class that is comprised of the case, the monitor, and the motherboard. So let's create yet another new class. We're going to call that PC. So it'll be our personal computer. And instead of using extends, we're going to type private case, the case. I have to use the word the case there, by the way, because if I just type case, as you know by now, case is actually a reserved keyword, so we'll actually get an error. So we need to put the case. We could have called it something else, but that'll do. So private case, so a PC has got a case, it has got a monitor. We'll just call these monitors. And of course, motherboard. And we'll create our constructor like we normally do. This time we're creating a constructor that's going to accept three different objects. And let's create our getters as well. So this is composition again. So we've created a new class called PC. It has a case, so that's the case variable, which is the field that we've defined. It has a monitor, a field monitor, and a field called monitor, and of course it has a motherboard, which is in this case is a field called motherboard. And you can see the obvious advantage here, because if you're using the extends option to inherit, you can only in Java inherit from one class at a time. So you can see that we run into difficulties and run into limitations quite quickly if we're using standard Java inheritance like we used in the last few videos, where we can only extend from one class. In this case, what we've said is the PC comprises of these three other classes, namely the case, the monitor, and the motherboard. So the PC has, in this case, is going to have the objects that we create based off this class will have an object case, monitor, and motherboard in each instance that we create. So let's actually run some code now and see how we would use this in reality. So what we want to do first is create a case. So we can put case, the case equals new case. So that actually needs the model number. So let's start with 220B. Manufacturer, well, let's use Dell for want of a better name. Power supply, we'll say 240. And lastly, it wants the dimensions. So it actually wants to know what the dimensions are. So we're going to just type dimensions in there. And of course, what we'll need to do is create a new dimensions class. So we could put so the dimensions, let's go with a width of 20, a height of 20, and a depth of 5. That would be our case. Weird size case, but for this example, it'll be fine. So that's our definition for a case now, remembering that when we create the PC, which we're going to be doing shortly, it needs this reference. It needs to know what the case is. And think of that as putting a PC together. A PC generally can't be put together without a case. So that what we're doing here is creating, or we have done is created the case. So next we need to create a monitor. So monitor, we'll call it the monitor, equals new monitor. And the parameters for this one needs a model. So we'll call it the 27-inch beast. Manufacturer, let's try Acer. Size, we'll go 27 for a 27-inch. And it also needs a native resolution. So we're going to create that. So we'll need to create that class. And let's do that a different way. I want to show you another way of creating a class on the fly. If you don't need to create a variable, you're not going to use it for anything else, you only want to pass it to a method, you can just type new resolution. And let's go for 2540 by 1440, which is the size of my monitor. So that's created a class without using a variable, which we don't need in this case. And I'll just fix that typo. That's monitor. So we've now got a case and a monitor that ultimately going to be used to create our PC. Of course, we now need a motherboard. So let's create a motherboard. So motherboard equals new motherboard. And we need a model. BJ200, and let's go with ASUS. Number of RAM slots, well, there's 4 RAM slots on this one. Number of card slots, let's just say there's 6. And BIOS, let's say it's version 2.44. So there's our motherboard. So now we're at the stage where we can create our PC. Let's put our PC together. How do we do that? Well, we type PC, the PC equals new PC. And of course, it then needs the case, the monitor, and the motherboard. They're the 3 parameters that will collectively make up our PC. So we've now created the PC class by passing those 3 other objects to it. Now, of course, you've seen in previous videos with inheritance where we're able to use a method name that is part of the basic class, the superclass in other words, but how do we get access to it? So for example, if I want to draw something using the monitor, how do I access this method? So of course, we've got the method drawPixelAt, but how do we access that? How do we access that from our PC? Because of course, the PC has got getters, but it hasn't got any way to access that. We're not overriding a method or anything like that. So how do we access it? Well, what we do, or one way of using it, we could type the PC dot get monitor dot drawPixelAt. So we could do it that way. We could do drawPixelAt 1500, 1200 in red. That's one way of accessing it. So what that is just using the getter function from here, which is returning the monitor which is the class that has already been initialized, the object which has been created in this class. It's returning that to the calling process. And from there, what we're then calling the method drawPixelAt, which is from that object that's stored within in the PC class itself, in the PC object, the instance that we've actually created, and that's invoking that method for us. So likewise, we could put the PC get motherboard dot load program. How would we load the program? Windows 1.0. We're doing the same thing there. We're getting the class, the object that's been created when we created the PC class. So we're accessing it within the PC object, and we're getting it to load, to call the method load program, which is in that object, which of course is in the PC object that we've created. And of course, likewise for the case, the PC dot get the case dot press power button. We could do the same thing there. So they're accessing ultimately these functions that are in these base classes, the case, the motherboard, and the monitor, but accessing them via the PC object. So this is what composition is. This is the difference than inheritance. The PC object that we've created here. So what we did to call the PC object was we created our case, our monitor, and our motherboard. And in reality, when you're putting a computer together, that's what you'd be doing. You'd go away and you'd actually buy the case, you'd buy the monitor, and you'd buy the motherboard, and you're then putting it together to build the PC. So in this case, what we're doing is we're passing these to the constructor, which essentially is getting those items and putting them together, which forms our PC. So the PC has a case, has a motherboard, and has a monitor. So this is the way when you're thinking of whether to use inheritance or composition, think about what you're trying to do here. In this case, we're trying to build a computer, and we need to access the case, the monitor, and the motherboard. We know that these things, the computer has got a case, it has got a monitor, it has a motherboard, and so therefore composition is probably a great way to go. But of course, a case by itself isn't a computer. A case isn't, a monitor isn't a computer, and of course the motherboard isn't a computer. They're part of a computer, but not actually the whole computer, which is why we're using composition here instead of inheritance. So I'm going to end this video here. We'll continue on talking about composition in the next video.